we might be needing those tonight. Hey, Milt, I'm on a conference call, or not conference call, but...
Hey, Jessica, really quickly, I need to get your last name.
Unstead?
No, I got it from you before, but I didn't save it, and I lost it. So I just need to get it from you again so I can...
Oh, no worries. It's UNSTED.
Okay, so it's just like your email.
Mm-hmm.
Perfect. Okay, thank you.
No worries. Alright. Oh, dang it. I don't have my glasses on.
All right, well, let's get going on the quiz. That almost seems like, I mean, we have to get that turned in tonight, so if anybody want to do any, I mean, I don't care if we do something else, but just kind of would like to just get that done if we could.
Yeah.
And it seems like if we, as we work through the problems, that seems like a better way to do it than just about anything else. What do you guys feel like? No.
Hey, let's burn it and go to bed.
Okay. Alrighty, let's do it.
Okay, hold up. Hey, Amanda? Amanda?
So how well did you guys understand this lesson today?
Not very well.
Can you grab my glasses for me? They're just on by my bed. Thank you.
Let's see, that's someplace else.
I'm like trying to do my stuff and I'm like, I can't see crap.
That's not good. All right, let's see.
There we go.
So it's not the homework, it's the group meeting quiz. Okay.
All right, now let's. So,
I frankly,
y'all going to soda bar?
I just can't wait until this class is over. I hate this semester. Hate both of my classes. I just decided to take two, but take hard ones and. Oh.
Hello.
Hello.
Hi.
Okay, all right. So I got 100% on question number 1. Yay!
Okay.
Okay, so let's see what the first answer is. I mean, the first question. Okay, which hypothesis equals equality? Well, let's see. That would be...
No, it's just me. That's not going to get mine. So, I'll get home from work in about a half hour. Is someone crying? No. Okay.
Have fun.
Can you turn off the TV, please? Thank you, sweetie.
Okay.
Where did I write that down?
Where are you guys?
So we're just starting on question number 3 about trying to see where my notes are. Which one is about equality? Let's see. State the null and alternate hypothesis that would use to test your claim. One-sided, one-tailed test. Line.
You're not going to school tomorrow. Wait,
Lucky.
Alrighty, let's.
So that's got to be, that is the null hypothesis that involves equality.
Yes, take your granola bar, please. And then why don't you read some stories, Hiram? Read ones that you can read, like Pete the Cat or Scooby-Doo or... No, honey, read the ones you can read to yourself. There's lots of stories you can read to yourself. You have Axel, you have Biscuit, you have... They're in your bedroom while you're...
Probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer the next question. Remember that the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. When computing the p-value, which hypothesis do you assume to be true? The null hypothesis.
Yeah.
Okay. Okay, so far not so hard, right? There's only 10 of them,
Just
so
because
we're already... Okay. Suppose the null hypothesis is mu equals 10. Use this information to answer the next 3 questions. Which of the following represents the alternative hypothesis for a two-tailed test?
That's
So that's got to be...
Yeah, it's the third one. Isn't it?
No, it's one of the ones that's less than or greater than. Wait. Oh, two-tailed.
Yeah.
Yes, not equal to. Yes, that's right. The other ones are just one tail, because you have to go either way, either less or minus, and you don't know which one, so it's two-tailed.
Which one are we doing?
So that was question 5.
Oh, wow. I totally spaced it. What did we get for 3 and 4?
Okay, so for 3 and 4,
null.
the null
They're both the null.
hypothesis is equality, and question 4 is the null hypothesis that you assume to be true.
Okay.
All right, so question 6.
Wait, what was 5? I'm
Okay,
struggling here.
It's number...
It's
It's
the
the
second from the bottom,
not equal to...
not equal to, because you can go either way. It can either be less or it can be greater than. So the tail goes both ways.
Okay.
Which of the following represents the alternative hypothesis for a left tail test? Now this I don't know. So
No,
it's got to
that
be
one-
one of the less than or greater than. Which way's
the
left?
It's the first one.
All right. So the less
The mean is less than.
okay. The
And
mean.
why is it the
And so
first?
how do you think? How do you visualize that in your head?
The tail is the small part of the fish.
But in terms of
Okay.
like left tail test, but how do you get the left part from the right?
Well,
Is
because
that-
look where the small part... like, imagine it is a fish, and there's a little tail coming off
that
of the
part I
triangle.
get. But so you're just saying it's pointing to the left. The small part's pointing to the left. And so that's what makes it left-tailed rather than right-tailed. Okay. So the...
Yeah.
Okay. Got it.
Yeah, so the next one would be the second one, right?
Sounds right to me, but
Yeah. This is surprisingly easy so far.
And y'all make me nervous when y'all say that.
I know, but I was like, oh, I should be careful, because the next question is going to be hard.
Okay, but at least it seems like there's a possibility to have some of these questions on there, so that's good. Okay. Ooh, well, that's an easy way to remember that.
So, okay, so the next question. Remember that we determined that the outcome of a hypothesis test by comparing the p-value is level of significance, or I don't even know.
Alpha. So that's alpha.
Okay.
Wow.
So which relationship would result in failing to reject the null hypothesis?
Okay. So that means. So what was that? He gave us, if the P is low, reject the null.
Reject the null.
Which relates
So wouldn't that be?
in
Oh,
failing to reject the null.
that would be.
So the P is high?
So if the P is high,
It
P
fails to reject.
Right.
fail to reject.
So it's the first one?
But is that for alpha? Is that for Z? It's for alpha, isn't it?
Yeah, so it's for the p-value. So it's the p-value as it's related to alpha.
Yeah. So if the P is greater than A, we fail to reject the null hypothesis.
Right. There we go. That's it. But that takes
rejecting
some
the
thinking, doesn't it? Look.
Well, I just read the textbook. Like,
Yeah.
it says in there.
Yeah. But it does take, I mean, you can figure that out from that. Okay. 9. Which relationship would result in rejecting the hypothesis? Okay, so that would be if the P is low.
Right.
So the p-value, so that's number 2, right? It's less than alpha.
Mhm.
Okay. And then we only have one more to go. Oh, no. Let's see. Oh, no.
It's a long one.
Oh, there's 21.
We're halfway.
Oh, all right. It's going to get harder.
Have faith. I have faith in us. We got this.
Hey, honey, you are just getting bubbles all over my arm. Thanks.
All right. Now we have to do some math. All right. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. Okay. They are concerned that the true mean is actually higher than this. Use this information for the next 2 questions. All right, so which of the following would be the appropriate alternative hypothesis? So not that the average claim amount is equal to $1,500.
The average claim amount is greater.
Is greater than $1,500.
The third one.
All right, there we go. Okay.
Woohoo, I got one right.
Okay, 11. Which of the following would be the appropriate null hypothesis? The average claim amount is less than $1,500. Okay, so that's 2 questions.
Wait, is it less or?
I thought it was
It would
equal.
be equal to. It would be, the null is the assumption of the status quo. Yeah.
So it's equal?
Yeah,
They are
that's
concerned that the the true mean is actually higher than this.
yeah.
Mommy, do you know
Not higher.
what? Do you know why I asked? What? Do you know why I asked? Why did you ask?
Why wouldn't you just want to do, because you can do higher than, why wouldn't you just do higher than if you think that's what it is?
Maybe.
If you think it's greater than, why wouldn't you just do that?
Well, they are doing that, but they have a null hypothesis. So they're setting up a test to see if what they originally believed is true or not. So the null, you could call their parameter, like it's their original thought, and then they're testing their alternative. So it's not that they're testing their null, they're testing their alternative to compare it with the annual, yeah.
Okay. So they're just starting out with that, and then through the alpha value, then they actually say what it is that they make that more clear that they're thinking that the claim amount is greater than 1,500.
All right, I
Right.
will be right back. 1 second.
Okay.
Oh, I did. And then do live with Pokemon. It was separate.
Okay, so
Ooh,
it's
That's a little scary. I'm
equal,
glad it.
not equal.
What?
It's equal, right? The first one?
Equal, yeah.
Okay.
That gets with the weather that and that was with
Okay, so the insurance company randomly selects N40 claims and calculates a sample mean of 1650. Use this information to answer the next 3 questions. Where is my calculator? There it is. Okay. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? Yes, because the sample size is large. Agreed?
Yeah.
Okay, got to be
Yeah.
that.
Yeah.
Okay, 13. What theorem or law justifies your answer to the previous question? That is the central limit theorem. Well, good. So we're going to be able to use this information more. That would be nice.
Yeah,
Get-
maybe we can
like
finally
to get
understand it.
points for stuff I already know.
Which-
Okay, which of the following is a test statistic as defined in this lesson? So that's got to be
I'm trying to find it right now.
That's the standard deviation.
mean, calculate a sample. Okay, but isn't that the statistic because they calculated a sample mean from the 40 claims? So it's X bar.
Oh, you're right.
Which one is it?
Well, I think it's X bar because they
That's
said
what I
they
thought
took a
too.
sample and then calculated it.
Oh, test statistic. Just a second.
Hey, sorry, I'm back.
Okay, so since we know, okay, so it says we need to determine how far X is from U. Since we know sigma in this case, we can use the Z-score to determine if X is as far from the assumed value. This is called the test statistic. So I think it's the Z, where Z is the test statistic, so it's Z.
Okay. Where are you? Is this in
Where
our
Z is the test statistic, yeah, is the sample mean. X bar is the sample mean, U is the population mean, and sigma is the standard deviation and is the sample size.
So, what letter is it?
So it's the Z.
It's Z.
Okay.
Z, sorry.
All right, so that's just in the lesson, so I need to write all that stuff down. Like, what part of that is that in the textbook?
4.2.
4.2. Okay, I need to write all those down.
Okay.
Yeah,
Do you want me to
that
give you the other
actually
numbers I can
made
read in?
sense because it says as defined in this lesson. Kind of gave us a clue there.
Could
Okay.
you quickly
Thank
go
you.
over 12 and 13 for me really quick?
Yeah, 12 is, it's a good assumption since the sample size is large.
Okay.
13 is central limit theorem.
Okay. All right.
And 14 is Z. I don't know if you heard it.
Yeah, I did. Thank you.
Why did you?
Okay, so now we got to figure out Z, huh? How fun.
All right. See, I like the one that can do formulas. I can do formulas.
Okay. So how do we set this up? So we have n equals 40. Bar equals 1650.
Oh, Yeah.
Oh, and so that's where the mu is the hypothesis. So which one do we use first?
So the first thing we're doing is determining a z-score with a sample size. So just like we've been doing before, where we first find the square root of n.
But it doesn't, so those are just two, the hypotheses. So she's got two different things she's testing for. So H is the mu, so the mu is 150. And what is the standard deviation? Does that say?
Oh,
$40.
no, I don't see this. Oh, there it is.
Yeah, standard deviation is $40.
Is what?
It's $40.
$40.
So
Is 40. Okay, so we have.
we have 36 sale receipts. Okay, so
There we go. Thank you very much.
Oh, a
So the square
standard
root of
deviation
36
of
is
$40.
right, and then
40 divided by
6.6666667.
Awesome. And what's,
So
what is 150 divided by that?
6. So
Oh, really? 6 even?
yep, 150 divided or minus 144.
No. We need to do 150 divided by 6.66666.
Why just 150?
Because we're finding the z-score, so
Yeah, I thought you had to
150
do
is the mean.
the value minus the mean.
Okay, so it's 1650 minus, I'm sorry, I'm behind. 1650 minus
No.
150. Isn't that X bar? So that's 1500
Just
divided.
like I'm where did I read this?
Because the X bar is the value, correct? So wouldn't you do 144?
I believe you. I just would like to see it written. No, I totally believe you. I'm just trying to see. Okay. Yeah, you're right. I'm just trying to. Anyway.
You're fine. It's okay.
What are we supposed to use in there? Because that's true, but I just thought it said. Oh, and she computes X bar is 144. Okay. So I guess we use that and not the 650.
Okay. Where are you?
Yeah, so then it's negative
664. I don't know what that other X bar was. Okay, so it's minus 6, negative 6.
So the answer I got was -0.9.
Okay.
What did you get, Jessica?
-0.9.
Okay.
For the z-score?
For the z-score.
40 divided by.
Yeah, that's what I got.
0.3.
Hey, how did you get that? Because I'm confused with the equation we're using here.
We're just using the equation we used in the last.
It's z equals x minus x bar minus x, which is 150, or u, I guess, over or divided by the standard deviation divided by the square root of n. So we know n is 36 because it says a simple random sample of 36 receipts.
Okay.
Okay.
And
40 divided.
the standard deviation at the top says it's 40. Like, do you remember which equation we're using?
40
Yeah.
Where are you finding this equation?
6,
That's why I'm having a problem. I don't
It's in
know.
our
6, 7. Well, so it started to give
It's in
us
the
numbers.
textbook under four.
It started giving us new
It's in the textbook under 4.2.
4.2?
I was looking there, and the only
divided by 6,
the only
6, 6.
oh my gosh, I can't think. Okay, sorry. The only formula I see is the one that was given to us last time.
Yeah, that's what we're doing right now is finding the value for Z. That's our first question is what is
Z is the
score?
Z, right?
So it's pretty close to,
Pardon me.
pretty close
Sorry.
to 1.
I'm
Oh,
in Canada and we call it Z here. So sorry.
that's okay.
Z.
Yeah, Z.
Okay. That's why I was getting confused. I was like, where does the Z come from?
It's from French, but in England they call it Z also. I think they do also in Australia and New Zealand. I think it's only you guys in the States that call it Z.
Okay.
Yeah.
That's reassuring because I was going crazy. I was like, where are we getting...
I am so sorry. And
It's
I don't know why, because I grew up in the States, so I always call it Z, and I don't know why I'm saying Z tonight. I think it's from having kids who go to school in Canada. I've switched over.
Ha!
Okay, so how come I got
Z.
-1? Darn it.
Z.
Everybody else got
Did you do-
-0.9?
Yeah, did you do -6 divided by 6.66666?
Well, where did I get this 59999? Oh, because I think I divided. Did I do that twice? So I
Bring
divided
it back again.
40 and divided it by 6. 6, 6, 6, 6, 6, 6, 6, 6, 6, 7.
Yeah.
Wasn't 40 the
We want to
standard
do 40 just
deviation?
divided by 6.
Did I add an extra step?
You're
in?
right, 40 is the standard deviation. Well, the square root, I think you heard Jessica and got mixed up because the square root of 36 is only 6. So it's just 40 divided by 6. Does that make sense?
Oh, yeah, 40. Well, yeah, okay. 40.
Probably if you're doing
Oh,
it,
no,
you heard
no. That's what I wrote down. Okay, 40 divided by 6 equals, and then that's when I get the 66666666667. 40 divided by 6. That's my
Right.
answer. And my,
So the Z score is 6.667.
No.
Right. No, the z-score is -0.9. Because then what we do is we take 144, which is z bar, or which is x bar, and we subtract that from, or we subtract 150 from it, which gives us -6. Because 150 was the original mean,
Okay.
and that gives us -6. And then we divide -6 by 6.6666, which is the new deviation,
okay.
or
I
the
got it.
sample deviation.
Yay. Oh, wait, now, now I got,
Hi, Dad.
Yeah, I'm just working on
I
16 right now.
-9.
Okay.
Oh, no, because it's 0.6. Shoot. Okay.
Hi,
Darn it.
sweetie. It's -0.9.
For the Z score.
Okay.
Yes, the z-score is
That's the
negative.
z-score, right?
Okay.
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 I got it too.
What is the p-value associated with the z-score from the previous expression?
So, the
P-value is probability, right?
probability of getting a result that is at least as extreme as the observed value. So what is the p-value associated with the z-score from the previous question? Oh,
They have a different...
I think you're right, Joseph. I think Yeah, I think you're right. I think we do put that into the normal probability applet.
Mm-hmm.
okay.
Okay.
I took notes on that.
So this is less than
Okay.
150?
What?
You put that
What
in
is the
normal
p-value
probability.
associated with the z-score from the previous?
And up here, it's 0.9. 0.9. Enter. Okay, and then we get
We shade in the area of both
for
tails.
both tails, right? Because it's double-sided. And so
Right.
then I get negative, oh no, I get 0.126 as the z-score. Is that what you guys got?
My z-score is negative 0.9.
Because I put that up in the area, I put the, oh,
That's the z-score, not the area.
put,
The negative 0.9 is the z-score.
Okay, so for the
Yeah, we want to put it in the
I didn't put, negative 0.9 is the z-score. Negative,
right.
oh, that's right, because that's what we solved for. Then what was he saying about the area?
So the area is our p-value.
Oh,
So if our z's or score is like 9.6 or whatever, then try putting in 9.6 in your normal probability applet. You're gonna get some crazy number.
so then the p-value for this question is 0.3681.
Yeah.
well 0.368 because you round to the third.
Oh.
Yeah.
Okay. Thank you. And then
At least the way I understand
I
it.
just want to clarify with everybody, and you tell me if this is right. The p-value is the probability.
yeah, and that's up in the area.
Right.
I swear, they keep giving me more symbols and words, and it's just confusing me.
Yeah, I'm
And
right
it's
there
saying
with
the
you,
same
so.
over and over again. Yeah.
Yeah.
So in this case, we failed to reject the null hypothesis, correct?
Because that's higher, right? Because that's higher
Higher than 0, yeah.
than 0.05.
Yeah. So
Yeah, 0.05.
Okay, I'm starting to get things now.
Now,
Okay.
is that right? Because it's higher than point
I think it
0.05,
must be,
so we
I don't think it's
reject.
0.05. I think it's just a second.
So the null hypothesis means that it's equal to the mean of the original, right?
Or it's just equal
Yeah.
to the original, whatever.
Yeah, the null hypothesis is just saying what we thought was correct is still correct. That's all the null hypothesis is.
So we're rejecting it, or are we failing it?
We're failing to reject it, but I'm trying to figure out why. I'm sure that's the answer. I just need to see what the parameters are
Now
for it.
it says if
Is
the
it
P
if the
is high, if the P is high, fail to reject, and so that is high. If it's 0.3, that's high then.
right? But like, what does high mean? Is high over 0? Like what? I'm just trying to understand
Right.
what does
So the
high
P
mean.
value, what we're trying to find is alpha is 0.05. So that's what we look at to compare all of our
Wait a second, guys. Hold up. It says if
So
the
where do
P
you
is low,
see that?
reject
I
the null.
see that. Right.
4.3 has a picture, and it shows, says large p-value, fail to reject. And that's
Fail to
Right.
reject. Yes,
So we
okay,
need to
that makes sense.
yeah, if the P is high, fail to reject. So that's
if
a
the
high
P is
value
low,
because
then-
Yeah,
it's
so-
like 10 times higher. It's more than 10 times higher.
Yeah.
So we have to.
In 4.5, if you guys are trying to find the section, and if you're trying to find the section, it's 4.5, and just like Sean is saying, if p-value is higher than 0.05, we fail to reject.
Okay.
Yeah, why do
Does that
they
make sense?
so many words to say something so simple?
Yeah.
I know, right?
I know these like math people who figured this out are probably brilliant, but the way they write this is stupid.
So did we have any? We didn't have any of those other things. Oh yes. So what is the p-value associated with the z-score? And does somebody have that handy?
What? What?
Number 16. I can just get it from my.
0.368.
It's what?
0.368.
0.68. Okay.
So what is your conclusion for this problem?
What is your conclusion?
We have sufficient evidence that true population is 150.
Is what?
Sufficient evidence that the true population mean is 150. That's the same, like that's saying that we're accepting null hypothesis.
Okay. So my question is, the big H with a little 0, is that the population mean, or?
No, that's the null hypothesis, and the H with the A is the alternative hypothesis.
Okay.
Yeah.
That makes a lot more sense.
There are two
Why
types.
can't people just speak English?
There are two types.
Math. All right. All right. So those errors. So if there are two types, which one involves rejecting the null hypothesis when the null hypothesis is true? So that's a true.
That's in section 4.5.
So that's a type 1 error, right?
Yeah.
Okay. That's like the most, just, that's bad. When you do that. Reject it when it is the truth.
Yeah.
Okay. So a researcher decided that instead of using a level of significance of alpha equals 0.05, he will use alpha equals 0.01. Which of the following will be true? Oh my gosh. That's really a lot to think about.
So it's still going to be a fail to reject, because it's still going to be greater than 0.01. So it should still be the probability of a type 1 error will increase, right?
You know, I cannot get my head around that at all.
Yeah, just give me a second to think about this, Joseph. I think you're right, but just give me a second. I'm slow tonight. Ugh. Okay.
Who uses this math in real life?
So if it's
Good night,
smaller
Mom.
than 0.05, it's
Mom.
even easier to.
Good night, honey. I love you.
It's even easier to accept. And type 1 is we're rejecting. No, I think it's type 2. Because if it's even easier to accept at 0.01, it's easier to accept the null hypothesis, then we're more likely to get a fake null hypothesis than reject it. Are you guys following me? Am I wrong on that?
No, I just don't get it. That is not making any sense to me. Oh, crap.
Okay, so if we're using 0.05 as a perimeter to accept, anything is higher than that, we accept it. If we go down to 0.01, it's even easier to accept things, right?
Correct.
Now,
Are you
why
following
is
this,
that?
Shauna?
Why is that? Why is it easier
Well,
to
It's easier to
accept?
have a number higher than
Because
0.01.
it's smaller than 0.05. So we have a larger space. So if it's 0.03, all of a sudden we're accepting it, whereas we would have failed it if it was 0.05. You got that? Are you following that?
No, but that's probably just one of those concepts I'm going to have to sit with.
Battle with?
Yeah. So I'll
Joseph,
get it. It'll come.
When I say that out,
so which one is
when I
that?
say that out loud, Joseph, do you agree with me that it would be a type 2 error would increase?
Well, I can't find a definition for a type 2 error.
Okay, so now that I have.
Okay.
So a type 2 error
Mm-hmm.
is, so he drew a little box. Oh, where did I put that?
If the A value is very small, the probability of committing a type 2 error will be large.
Okay, so say that. If the what?
If the A value is very small,
okay.
So if we shrink it below 0.05, the probability of committing a type 2 error will be large. So type 1 is if we reject a true null hypothesis. A type 2, from what I'm understanding, is if we accept a rejection of the true null.
Okay,
It's the opposite.
y'all can hear me now.
Sorry, I said that so bad.
So a type 2 error is if the null we fail to reject the null hypothesis, but it's false. So
Yeah.
that's a type 2 error.
So isn't that another way of saying we keep a false null hypothesis?
Yeah.
Why can't they
Okay.
just say that?
I know, right?
Jeez.
Okay, so from the textbook, though, the probability of a type 2 error will increase.
Okay.
Where are you finding that? Because I can't even see.
Okay, so
It's in
if
the
you
summary.
go to section, well, it's in the summary, but it's the exact wording that I found. It's in section. Just let me get it again.
It's in the summary?
No. If you go to section 4.5, it says type 1 and type 2 errors. And then, like, the third paragraph in, we choose A to be some small number, so that committing type 1 error is low. Oh, where did I find it?
If the A alpha value
Yeah.
is very small,
And
the
so you see the
probability
truth
is
box,
large.
and then it's 2 paragraphs under the truth box.
Oh my gosh, I don't know why I decided to take this online. I could have just taken this in class, and that would have been so much easier.
Okay, now I'm understanding, because at least I can find where it says. I couldn't even find where it said type 2 error anywhere in here. So I couldn't find
I can't either except for at
so.
the end.
Okay.
Okay, anyway, so last question. Woohoo!
So if alpha equals
If alpha-
0.05, compute the probability of committing a type 1 error.
How do you even do that? Why would they even ask that?
It doesn't say that in the textbook.
I know. I have no clue. What?
What is the probability of committing a type 1 error?
So does that mean getting a result that is 0.05 away from the mean?
sorry, I'm like, yeah, 0.05 is the measure we're working with, but I don't know how to determine the probability, like, that we would
Do we
get a type 1
do we
error.
find what 0.05 away from the mean is?
Away from what mean? Can you, like, tell me what your line of thinking is here?
Well, I don't know what the A even stands for, besides that it's small.
So
Oh,
that
wait, you know what we can maybe do? Go to the... Just, I'm typing it in the normal probability applet. What does it mean?
Wait. Okay. So the level of significance, the alpha, is standard for determining whether or not the null hypothesis should be rejected.
Right?
Typical values for an alpha are 0.05, 0.1, and 0.01. If the p-value is less than the alpha, we reject the null. And if the p-value is not less than the alpha, we fail to reject the null. Okay? So I just read a whole bunch of crap that doesn't really matter. Oh man. Guess who's
okay,
gonna
so the homework. Here this is on the homework. If we tested this hypothesis at A, alternative hypothesis, is a 0.01 level, what is the probability of committing a type 1 error? Explain your answer. So that's number 9. It
On the
says,
preparation lesson or the homework?
from the homework, the probability of committing a type 1 error is alpha equals 0.01. So let's...
Why?
Well, and do those numbers... Okay, so let's just say that that's what it is. If it says the type 1 error is at 0.01, let's just say that that's... the answer is 0.05. How about that? To say that that makes sense. Oh.
This is crazy.
Can we just put a random number down and then just go with it?
But I think it might be 0.05 because in the homework example, it says 0.01 is the level. What is the probability of committing a type 1 error? And the answer is it's 0.01. So maybe that's it.
Agree with you. I'm just trying to understand why. And where,
I
like, where
know.
does it say this?
Okay,
You know,
so you guys, I'm gonna go tomorrow. This isn't gonna be a question. I need to go to the math center, the math tutoring center. So if they understand it, I can try to explain it to you guys and send you guys an email.
Oh,
And
thank you.
Yeah, that would be great.
so either that or I'll probably record it because I have a voice recorder, and I'll probably record it and then just attach it to an email and send it to y'all.
Okay, well that would be outstanding.
Because
thank
I'm looking at this and I'm like, okay, there's no way I can do this without going to the testing or the tutoring center. So I'm like, okay, looks like I'm gonna go to the tutoring center tomorrow. Oh man.
Oh, you're lucky. That's nice to be on campus and be able to...
Yeah, I'm
Go
glad
in.
I didn't take this on like online, like off campus. That would have, oh my gosh, that would have sucked.
It does suck.
Yeah,
I'm living it right now.
You what?
But it does suck. I'm living it right now.
Yeah, it's a hard thing. Okay, so are we going to submit this and see? Has anybody have submitted their quiz
What
yet?
did you put for 21?
0.05.
So the probability is 0.05 when the little fishy looking thing is 0.05.
Okay, so that's alpha. So just call it alpha.
Okay.
I like the fishing little
Then
thing.
you'll
though.
sound like all, if you call that alpha, it sounds like,
Wait, wait.
rest.
What do you mean by the fishy thing? Are you talking about the A or less than signs?
No, he's talking about the alpha.
It doesn't have the end of the tail on it. It's a Jesus fish, but it's backwards without the tail.
That's the best description I've heard of that so far. Okay, I'm just gonna submit the quiz and go for it. All right, you guys. Let's see. 2, 2, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Oh, we missed one. Question number
Which
16.
one? The one
Six-
that we can't figure out. Oh.
No, 16. 18. 16 and 18. The rest of it we got right.
Awesome.
It
Thank
is 0.05 for 21.
21, the answer is 0.05.
Oh my goodness, this is crazy.
18 we got wrong?
16 and 18.
So the p-value, yeah, we got the p-value wrong, and
I wonder if it's that we have insufficient evidence the true population mean is 150.
That could be it. I don't know, you guys. To be honest, I'm happy with getting a 91. I don't want to retake the quiz.
Yeah, I know, right? Well, if you want to go, Jessica, that's fine. Like, if you're done.
My brain is done. I can't wrap my head around this, so I have no idea how to figure out the
Oh,
answer.
I'm
You guys
really-
have done most of it.
What is the p-value associated with the z-score? What?
Okay. So how do we know that it's a two-tailed thing?
because
How do
it's
we know
not,
it's two-tailed?
because it's a not equal to. So so it can either be either less or it can be minus.
Well,
So,
the alternative hypothesis is a left whatever. Because the fishy, remember the tail is on the left, the smaller side. So wouldn't you just do whatever's on the left, so less than whatever the 0.9,
That's a
the negative
point.
0.9? Am I making sense?
Yeah,
Sorry,
that's
I'm not following you. What is
Okay.
your question?
so number 8. Which question?
Okay, so this is number 16. Okay.
Oh, 16.
Right?
So I'm wondering why it is two-tailed. How did we figure that out?
What do you mean by two-tailed? I don't see that term in question 16.
Well, okay, so
I guess
in order to figure out the p-value, we have to figure out if it's two-tailed, left-tailed, or right-tailed.
Oh, yes, because that's when we shade in the sides. So either where we shade in the normal probability applet.
Yes.
Right. So if it's two-tailed,
So
then we
I
have to
think what's wrong.
then we have to shade in both sides.
So that's
because it's
if it's two-tailed.
less than,
This is left-tailed.
because it's a less than symbol.
Yeah.
Okay, so
So much sense.
the symbol points the direction that we're supposed to be filling in. So since it's an arrow pointing to the left,
You fill
then
in the
we
left.
fill in the left.
Yes.
Okay, so we undo the right side of the probability applet.
So it should
Yes.
be 0.184.
Yes.
What?
Oh,
Point-
thank you.
0.184.
Yes.
Okay, that makes sense.
Okay. So, what is the conclusion for this problem?
Okay, so I guess they say fail to reject, but it doesn't say accept. So my guess is our conclusion is that we don't have sufficient evidence that the true population mean is 150, but we're not failing to reject it.
So I think it's the third one, number C, or letter C, sorry, because earlier it's the less than symbol. So the alternative hypothesis is the mean is less than 150.
I think you're right. That makes sense.
Or fail to reject that. So it's we have yeah. Okay. All right. Cool.
So
Less
the answer is we have insufficient evidence that the true population mean is less than 150.
Yes. Now,
Okay.
if I retake this, can you guys tell me the answers?
Yeah.
Okay. All right. Let me quickly do that then.
Yeah, that's correct.
Is that correct? Did we
Yeah.
get it all right now, Joseph?
Yes.
All right. So what is this group 9 or lesson 9? Yeah. Okay. All right. So if you can just say number 1 or well whatever number 3 and then the answer, that'd be great. So 3 is
null.
null. Okay.
Okay, I'm gonna get out of here. I gotta go to bed.
Have a good night, Joseph.
All right, good night.
Sleep well.
Thank you.
4 is null.
Null.
Yeah.
Okay.
5 is the two-tailed, which is the third one down.
Right.
6 is left-tailed, which is the first one.
Yep. Right, which is the second one.
Yep. 8 is the value is greater than alpha, so it's
okay. So it's the first one.
yeah. 9 is the second one.
Okay.
P-value is less than alpha. 10 is the average claim amount is greater than 1,500.
Okay.
11 is the average claim amount is equal to 1,500.
Okay.
12 is it's a good assumption since the sample size is large.
Okay.
13 is central limit theory.
Okay.
14 is Z.
Okay.
15 is 0.9 or negative 0.9.
Okay.
16 is 0.184.
Okay.
17 is fail to reject.
Got it.
18 is the third one. We have insufficient evidence the true population mean is less than 150.
Okay.
19 is type 1.
All right.
20 is the probability of a type 2 error will increase.
Okay.
And 21 is 0.05.
All right.
All right.